Hello. So we are going to be solving this problem on mirror. Okay. So it's a question that is kind of tactical. Okay. So let's check out the question and then we'll solve the problem together. Which of the following expressions gives the linear magnification produced by a concave mirror of radius of curvature R if U and V are the object and image distances respectively? Okay, now we have this question on the board. So the first thing you need to do is just to bring out the parameters that are given in the question. Okay, so we pick out the parameters from the question. From there, we'll know what to do. So let's check it out. Which of the following expression gives the linear magnification? So it means we are looking for linear magnification. Do you still remember the formula for linear magnification? Simply put, magnification. Okay, it is symbolized by M and it is given as what? V over U, where V is the image distance and U is what? The object distance. And of course, M is the magnification. So produced by a concave mirror of radius of curvature R. Okay, so we have R. What is R? R is simply the what? The radius of curvature. And if you remember the relationship between focal length and radius of curvature, do you still remember? Focal length is equal to what? Half of radius of curvature. Focal length is equal to what? Half of radius of curvature. What does that mean? It means that what? We have what? F to be equal to what? R over 2. Okay? Okay, we have gotten this information now. Let's check out the next. If U and V are the object and image distances respectively. Okay, so it means in this question we are giving V to be V, we are giving U to be what? U. What are we looking for? We are looking for what? Magnification. Of course, we know that magnification is simply V over U. But when it comes to what we are given now, we need to apply it into the mirror formula and then we find the linear magnification for this question. Okay, do you still remember the mirror formula? The mirror formula is simply 1 over F is equal to what? 1 over V plus 1 over U. Okay, so all that we have gotten from the question, we are going to inject them into this formula and then we'll find the linear magnification for this question. So let's do this. 1 over F. F in this case, we have R over 2 as our F. So we have 1 all over R over 2 is equal to 1 over V. V is V here. Okay, plus what? 1 over U. U is simply U. So we have 1 over U. Of course, this is inverse. So inverse simply means the denominator comes up, the numerator comes down. But if you want me to still show you, some of us don't really understand inverse. It's simply 1 divided by R over 2. Okay, if I'm to change this to multiplication, it means that we'll have what? 1 times what? 2 over R. Okay, are you seeing what I'm doing? So 1 times 2 will give me what? 2, and then we have 2 over R. So it's simply the inverse. Okay, I've shown you how the inverse came about. So we have this. So it means that this is simply what? 2 over R is equal to what? 1 over V plus 1 over U. Let us multiply both sides by V. Let's multiply both sides by V. If we multiply both sides by V, we'll have this 2 all over R times V is equal to what? 1 over V times V, right? Plus what? 1 over U times what? V. Okay? So, this will give us what? Simply 2V over R, and then V will cancel V, and then we are left with what? 1 plus V will cancel this V. Okay? We'll be left with 1 here. 1 over 1 is equal to 1 plus V over what? U. Remember, this is what we are looking for. V over U is what we are looking for. Of course, there's no M here, so we cannot make M the subject of the formula. So the only option is to make V over U the subject of the formula, and V over U is the same thing as what? Magnification. So let me wipe this other side so that we can continue. So wiping the other side, let me recopy this to this part. So we have 2V all over what? R is equal to 1 plus what? V over U. Okay? I want to make this the subject of the formula. How do I achieve this? How? We subtract 1 from both sides. Okay? If we subtract 1 from both sides, this becomes the subject of the formula. Let's do this. So we have 2V all over R minus 1 is equal to what? 1 plus V all over U minus 1. Plus 1 minus 1, we go. This we go with this. And then we'll be left with what? 2V all over R is equal to what? V over U. And then this is, no, minus 1. I missed minus 1. Minus 1 is equal to, okay? Is equal to, right? So this is the answer. So we have V over U, this which is the magnification, is equal to what? 2V minus 1. This is the answer. This is the final answer. V over U is equal to 2V over R minus 1. Okay? Of course, you know that V over U is the same thing as what? Magnification. Okay, so let's check our options to see if we got this answer. Okay, maybe we'll find our options, maybe we wouldn't. So let's see. We have 2V over R minus 1. V over R minus 1, no. 2V over R minus 1, yes. So our answer is what? Option B, which is what? 2V over R minus 1. So it means the linear magnification produced by a concave mirror of radius of curvature R is equal to what? 2V over R minus 1. I hope you enjoyed today's problem solving. I'm still Bukola Joseph, the physics enthusiast. Bye.